I have one more example I need to go through for implicit differentiation. I've thought about leaving this one off of this section, but because it's really key, and as far as it's the only time that we've actually been plugging in numbers, I want to go ahead and do one more implicit differentiation, and it's asking me to actually find that derivative at the indicated point. So I'll go run through this really quickly. Take the derivative of x cubed, which is 3x squared, plus we have 3y squared dy over dx. Remember, I'm using the dy over dx instead of the y primes. Equals, please pay attention that you do have product rule here. The two pieces I'm going to use is, this is going to be my first term, the 6x, and the second term is going to be y. So I'm going to start out by saying first times the derivative of the second, the derivative of y would be dy over dx, plus the second, y, times the derivative of the first, which would be 6. And then I'd have plus 0, which I don't need to write. This is, the derivative of that is 0. Collect my dy over dx's on one side. So I'm going to move everything to the left-hand side. That's a dy over dx. So I'll have 3y squared dy over dx minus 6x dy over dx equals, I'm going to move my 3x squared to the other side. So I have a 6y minus 3xy, or 3x squared. Third step, factor out your dy over dx. I'm going to take that out of both of these terms. I'm left with 3y squared minus 6x equals 6y minus 3x squared. Divide by 3y squared minus 6x on both sides. And my final answer would be dy over dx equals 6y minus 3x squared over 3y squared minus 6x. Now, it did tell me to evaluate this at 2, 3. So I'm going to plug in the 2 for all my x's and the 3 for all my y's. So this is my x value, this is my y value. So I have 6 times 3 minus 3 times 2 squared all over 3 times 3 squared minus 6 times 2. dy over dx comes out to be the number then of 18 minus 2 squared is 4 times 3 is 12. I have 27 minus 12. And I end up getting 6 over 15, which I could then reduce to be 2 all over 5. So just as it with regular derivatives, we have a general derivative, and then we have a more specific answer once you plug in the numbers.